Question 24. If A, B, C, D are the midpoints of the quadrilateral PQRS as shown, prove that ABCD is a parallelogram. So we have asked you this question earlier, and here is actually the solution of the problem. So what I've decided here to give you a hint so that you can write down the details and your solution. So I'll tell you the approach to solve this problem, right? Now let's try to understand it. So we have any quadrilateral, right? So that means I've purposely drawn one in which none of the sides are equal and none of them are parallel, right? So that's a kind of general quadrilateral. Points A, B, C, D are the midpoints of the four sides of the quadrilateral. So when you join these midpoints, the figure doesn't show that they are like parallelogram, but when you do it exactly, then you'll see that ABCD is a parallelogram. The idea here is that we have to prove that it is a parallelogram. Okay. Now we'll start with the strategy. Here is that if you look at these two triangles, I've actually constructed this. That is, I joined this S and D to prove that ABCD is a parallelogram. Now what I'm trying to do here is, I'm trying to consider two sets of triangles. So first set which I'm considering is, let me write down here. You see this big triangle, which is, let's say, SPQ. Okay, so let's call this triangle, big triangle SPQ, SPQ. And a smaller triangle right there, DPA, and the triangle DPA, right? So now in these two triangles, you will notice that if I write the ratio of the sides, we already know this is the midpoint. Midpoint means this side is equals to that side, and PA equals to AQ, right? Now if I write ratios of the two sides, first for the big triangle, big to small, right? So big is PS. If I write PS over PD, and on the other side, if I write PQ over PA, we know that PAS is twice as PD, right? So they are equal. They are both 2 over 1, right? Since PD is half of PS, right? So if this total length is, let's say, 2 units, then PD is 1 unit, right? So the ratio of this is double as compared to this half, right? So what we see in these two triangles, that their corresponding sides are in a fixed ratio. That means the triangles are similar, right? So we proved that they are similar. So that's a strategy. Construct this line and show that we have two triangles which are similar. Now that also means that the ratio for SQ, that means SQ over DA, is also 2, right? That means DA is parallel to SQ, correct? And what? And DA is half of SQ. Is it okay? Or SQ is twice, so half of SQ, right? So this is what it means. Now, so this part we have done. Now consider the other set of triangle, which is triangle SQR, right? So let me write this SQR triangle now. So we are considering now triangle SQR, the other side, and triangle CBR. See, it is important when we are writing triangles, we follow a pattern, right? CBR. Now, B is the midpoint, right? So we know these two sides are equal. It's a midpoint. So it divides into half. That means the ratio of QR divided by BR is 2, correct? As we did earlier. Do you see that? Similarly, these sides are also equal. Correct? So again, from here we can show that these two triangles, the big one and the smaller one, are similar. Do you see that? You can fill in all the steps. So this implies that these two triangles are similar. Now once they are similar, then we know that this side is parallel to this side also. So we prove that SQ is parallel to CB. Correct? SQ is parallel to CB. And we also prove that CB is half of SQ. Correct? So we have proved that CB is parallel to DA, right? And now we say CB is half of SQ, right? So we prove, look here. Now if you compare 1 and 2, then we know that CB is equals to DA. Correct? So there are two things. One, they are parallel. Second, they are half of this. So they are equal. Same directions, right? So we have proved that these two are parallel and these two are equal, right? So at least two sides, one set we have proved. It belongs to a parallelogram. But to be doubly sure about it and to complete our answer, what we need to do is we'll do a similar type of proof by joining line PQ. So when I join PR, you join PR now. Now if you join PR, do the same thing for these two sets of triangles. What I'm trying to say is you'll also see now when you join PR that triangle PQR and A is similar to triangle AQB, right? And then if you look at that side, you get triangle PSR is similar to triangle DSC. And thereby, you can prove that these sides are parallel and also equal. Now you have proved that all the four sides belong to a parallelogram where the opposite sides are parallel and equal. And therefore, this is a parallelogram. Well, in the whole proof, I have not used them as vectors because the whole, I know, we are dealing in vectors. But the question really is a geometric problem. And so we have dealt it like this. In case the question is modified and we say that prove that vector dA is equals to vector CB, in that case you'll follow the same steps and you have to show the directions and make them as a vector, right? So that is what I'll suggest. So the idea is to try to explain you how to prove such problems. It's not an easy problem, right? So first part is construct. So it was possible to prove because we constructed SQ, joined that line S and Q, and that made us see two sets of similar triangles, and that helped us to prove that the opposite sides are parallel. So that is the kind of approach which you need to adopt to solve such problems. I hope you appreciate that part, right? And according to the question, answer it, and I hope that should be good and you take something from here. Thanks and all the best.